All right, in this how-to video, we are going to look at the various ways to calculate or use pH, pOH, the hydronium concentration, and the hydroxide concentration. So I'm primarily focusing on this handout, which shows the different calculations you can go. And I have a few example problems here. So the first thing I want to look at is going from pH to the hydronium concentration. And to do that, I'm looking for the pH from the hydronium concentration. So we're going to use this path here. pH equals the negative log of H3O plus. So my first sample is the hydronium concentration is 1 times 10 to the negative 6. This really helps us out and makes our calculations really simple. So if we do pH equals the negative log of 1 times 10 to the negative 6, and we type it into our calculator, it works out easily that it is just 6. So our pH equals 6. This only works when we have a 1 here, so it's just 1, and this is a whole number. But when you do that, it does come out nicely to be just that 6. So looking at the next one, sometimes we give you the concentration like this, and it's not in scientific notation. Well, we could put it into the equation pH equals the negative log of 0.0001, or we could convert this into scientific notation, and it would be 1 times 10 to the negative, and we're going to move it 1, 2, 3, 4, to the negative 4. So our pH here is 4. And if you type it into your calculator, negative log 0.0001, you still come out with 4. All right, it becomes a little trickier when we look at the next problem where we don't have that nice, simple scientific notation. We can put this in scientific notation. It'd be 2.74 times 10 to the negative 3. But again, we're not looking at a 1 here, and we do have a nice whole number there. So we're going to have to do the equation and use our calculators for this. So I simply type it in on my calculator, negative log 0.00274, and I come out with a pH equaling 2.56. Okay, so that's just simply using that equation. Moving to the next part, this would be trying to get this concentration from our pH. So I'm going to use the concentration equals 10 to the negative pH. So our first sample, pretty easy, pH is just 5. So we do the concentration equals 10 to the negative 5. So in your calculator, you're going to write 10 caret negative 5, and you come out with an answer of 0.00001, or in scientific notation, 1 times 10 to the negative 5th. Right? That would be your concentration. So when we have whole numbers, it makes things so much easier, but we don't always have whole numbers. So our second example, we're going to use 4.3. And we do the concentration equals 10 to the negative 4.3. Put that into your calculator, 10 caret negative 4.3, and that comes out to be 5.01 times 10 to the negative 5th. So a little bit different in our concentration, a little bit harder, but still just using these same equations of here and here. Now, one thing I want to look at is doing it the other way, looking at the base side of it. pOH is not something we normally work on or work with. We hear a lot of the pH scale or where it fits on the pH, but pOH is looking at basically the same thing, but concentrating on the OH minus ions instead of the pH ions. So doing similar, exact same things, if we want to find the pOH when we have an OH minus concentration, and again we have the 1 here and a whole number here, it's simply just that whole number. So if the concentration is 1 times 10 to the negative 4th, we are looking at a pH or pOH of 4. Here we can again put it into scientific notation. Our pOH would equal 2. You can plug it in, you can say negative log of the OH minus, and that would work. But again, if it's easier, work smarter, not harder. Now this last one though, that one is going to be a little bit more of a challenge because we don't have that nice easy whole numbers that we're working with. We're working with kind of this different, or one with different digits. So we have to use our equation, negative log of 0.00763. And that comes out to be 2.12 for our pOH. So again, we're really not doing anything different than we did on the pH side, but our numbers are looking at the OH minus ions in our solution instead of the H3O plus or the H plus ions. Okay, we can look at the other side of it and try to get the concentration from the pOH. When it's a whole number and it's simple like this, our OH minus concentration is 1 times 10 to the negative 7th. So that's pretty simple there. When we don't have a whole number, that's when we're going to have to use the equation. OH minus equals 10 to the negative 10.2. So we just type into our calculator 10 to the negative 10.2. And we come out with 6.3 times 10 to the negative 11th for our concentration for OH minus. So this side, or these last examples, I was more focusing on this side of our little graphic here, where pOH to the concentration, we're going to use 10 to the negative pOH. The OH minus concentration to pOH, we're using that negative log. If you notice, both sides of this graphic have very similar equations. The difference is the concentration of H3O plus versus the concentration of OH minus, or pH and pOH. So we're just kind of looking at those things. All right, now what I'd like to focus on is a very simple equation of pH plus pOH equals 14. So say I have pH and I need to know the concentration of OH minus, or the pOH of the system. So very simply I say 3 plus pOH equals 14. Mathematically I can do that in my head, but really we're going to subtract 3 from both sides and we're going to say pOH equals 11. That's really as simple as it could be, except for when we go and do something like this where I have the H3O plus concentration, but I want to know pOH. So there's a couple ways we could do this. We could take our concentration and we could find the concentration of OH minus and then go up to pOH. Or we could go up to pOH and then find the and then find pOH. So I think I'm going to travel this path. It's an equation that we've been working on. It's a little bit nicer than this mess down here. So we're going to say pH equals the negative log of 0.0027, and go ahead and put that into your calculator. And we come out with 2.57 when we round it. Now, this is the pH. We can use this equation to figure out what the pOH is. So subtract 2.57 from both sides, and we come out with pOH equals 11.43. All right, so that is using this equation here, or going back and forth between the pH and the pOH. Our last bit is looking at the difference between the concentration of H3O plus and OH minus. So I have a couple of samples here. The first example, I'm just given the H3O plus concentration and asked for the OH minus. So I'm going to plug it in to this equation we have here. 2.3 times 10 to the negative fourth times OH minus equals 1 times 10 to the negative 14th. Well, all I have to do is get OH by itself by subtracting, or by dividing by each side, 2.3 times 10 to the negative fourth. And that comes out to be 4.35 times 10 to the negative 11th. The next example that I have is a little bit more challenging because I want to know this, and I'm given this. Now, I could go across here and figure out my pH, and it could go down and then use this equation to figure out my H3O plus concentration, and you are perfectly welcome to do that, and it is a valid method. However, I want to practice this equation down here, so I'm going to convert to my concentration and then use my concentration equation to get over to here. So this is just another way to show you a different path. The path you choose, as long as you're following the right equations, then it's going to give you the right answer. So the path I want to figure out what pH is if pOH is 8.3. Oh, no, I don't want to do that. I want to do the concentration of OH minus equals 10 to the negative pOH, or in this case, 8.3. So we're going to do 10 to the negative, and we come out with 5.01 times 10 to the negative 9th. This one we can now stick into this equation. So we have H3O plus times 5.01 times 10 to the negative 9th equals 1 times 10 to the negative 14th. Divide both sides by our OH minus concentration. And we come up with an answer of 1.996 times 10 to the negative 6 as our answer for that. So again, these were just sample problems of working our way through from concentration to concentration, or pH, pOH, trying to figure out OH minus from pH. The paths you use in working on this worksheet or working through this graphic is totally up to you. Just make sure that you're following the arrow and using the equation that goes with that.